Hey, hey, hey. Okay, first problem to applying this digital logic truth table to a problem, the knights and knaves problem, is the blue and red. So we crash wreck on an island and two people come out. One is blue and one is red. And the blue person comes out and says, "We are both knaves." So where this problem starts out is we have knights and knaves. Knights always tell the truth. Knaves always lie. So before I start doing anything else, I wrote out our two variable truth table. So we have blue and red. And to start out, I have blue, and all outcomes of this, we have a true, true, false, false, and now a true, false, true, false. So that covers any outcome of blue and red lying. So to start this out, I drew a table over here with blue and red, and I'm going to use the letters I to symbolize knight, and I'm going to use A to symbolize knave. So it kind of stinks, knights and knaves all have the same first two letters, so I had to get creative. But basically what this is going to come down to is I'm going to take the statement that we're given, which unfortunately is just the word of blue, and I'm going to say use this table to decide the outcome for what they are. So over here I have blue is true. So if blue says we are both knaves, that would make blue a knave and red a knave. And because red doesn't say anything, we can just go on to the next one, which is we are both knaves. Since blue, I have the truth table, him still telling the truth, that would mean they are both knaves. Okay, third time he says it, we are both knaves. On my truth table, I have him as lying. So that means if he's lying, he can't be a knight. So he would still be a knave. But if he is lying when he says we are both knaves, that would make red a knight. And then on this bottom statement, we have we are both knaves. That would make him lying, so that would make him a knave. And then false would be we are both knaves, so that would make red a knave because red would also be lying. So, and then what, oh, I'm sorry, that would make red a knight, just like it was before. So then after we have the statements, the two tables next to each other, we can go down, and what you want is you want the tables to overlap. And what I mean by that is we know that knights always tell the truth. So that means we're going to want a T on the left table where there's an I on the right table. And then knaves always lie, which means we want a false where the A is. So if we come over here and we have true, true, A, we can just consider these as falses. So we'd have true, true matches false, false. And we know that's a lie, or that's not true, so we'll cross that out. Next we have a true, false matching with two knaves, which is two falses. So we know that's true, and or false, and I'll cross it out. Next we have false, true matching with knave, knight, which is false, true. So that one's match. And then here we have false, false equals AI, which would be false, true. So that one's not true. So using this table and going through, we would now know that red is a knight and blue is a knave. So I went through that kind of quick. These problems can get kind of difficult. The best way I found out to do them is just to draw them out and see more of them, and I'm more than willing to do more. So if you want to see more, stay tuned because I'm going to be making them. And until next time, have a good one.